Assalamualaikum and good day to everyone. So today we'll continue with chapter 4 bipolar junction transistors or BJT. Okay, now let's start with the transistor structure and operation first. Okay, so the BJT is constructed with three doped semiconductor regions called collector. Here is the collector or C, and then we also have a base or B, and finally an emitter or E. Okay, and there are two types of BJT, and there are NPN and PNP. Okay, so can you spot the difference between these two? Okay, can you spot the difference? Okay, so for the NPN, it is constructed by two N regions here, which are separated by the P region. Okay, and while for the PNP, it is constructed by two P regions and separated with N regions. Okay, and the PN junction here joining with the base and collector is called as a base collector junction, while the PN junction here, okay, joining with the base and emitter is called as a base emitter junction. And this is also true for the PNP BJT. Okay, so this is the base collector junction, BC junction, and this is the BE junction. Okay? Okay, now let's look for the bias arrangement for the NPN and PNP. So again, can you spot the difference between these two types? Anyone wants to try? Okay, so the difference actually lies between the polarity of the VBB and VCC here. Okay, so as you can see here, for the NPN, the polarity is minus plus, and then for the PNP, it is plus minus. Okay, and then for the VCC, for the NPN, it is minus plus, and for the PNP again it is plus minus. Okay, so the polarity is different, but for the both type, the VBB is actually forward bias, the BE junction here. Okay, so it is actually narrows the BE depletion region, and same goes to the PNP. The VBB is forward bias the base emitter region, base emitter junction. Okay, and for the VCC, it reverse bias the base collector junction. Thus, it is actually widens the base collector depletion region. Okay, so same goes for the PNP. The VCC reverse bias the BC junction. Okay, so we can say that for the both cases, the PE junction is forward bias, while for the BC junction is reverse bias. Okay, so it is same for both types. Okay, now let's look for the current flows for the NPN and PNP. Okay, so for the NPN, the current flows from the base and from the collector to the emitter. Okay, so this is IB, IC, and IE. Okay, and for the PNP, it flows from the emitter to the base as well as to the collector. Okay, and then we know that current in equal to current out, right? So we can write the equation for the current where IB plus IC equal to IE. And for the PNP, sorry, this is IE. So IE equal to IB plus IC. Okay, so for both type or for both cases, we can say that IE equal to IB plus IC. But please note that the base current is actually very small if compared to the emitter current or collector current. Okay, there are two important parameters to analyze the transistor circuit, and they are DC beta and DC alpha. The DC beta is actually the DC current gain, and it is the ratio of the DC collector current IC to the DC base current or IB. And the typical value range for the DC beta is from 20 to 200 or higher. And for the DC alpha, it is actually the ratio of the DC collector current IC to the DC emitter current IE. And the range is from 0.95 to 0.99 or higher. Okay, now let's do the current and voltage analysis for the NPN circuit. Okay, so to do this analysis, let's divide this circuit into three parts. Okay, so for the first part, okay, this is the first part. Okay, so when BE junction, this is P, this is E, and this is C, right? So when the BE junction is forward biased, it actually acts like a PN junction diode, which has a nominal voltage drop of 0.7 volt. Okay, so we can say that VBE equal to 0.7 volt. And then as the emitter is at ground, okay, this is ground. Okay, the voltage across RB or VRB, okay, can be found using KVL. Okay, so using KVL minus VBB plus VRB plus VBE equal to 0. Okay, so VRB equal to VBB minus VBE. Okay, so this is question number 1. And then using Ohm's law, we know that VRB equal to IB RB. So let this be question number 2. Okay, so by substituting 2 into 1, we will get IB RB equal to VBB minus VBE. Okay, so the current across RB or IB equal to VBB minus VBE over RB. Okay, so this is the current across RB. Okay, now let's consider the second part of the circuit to find the VCE. Okay, so this is the second part. Okay, so again using KVL, we can get minus VCC plus this is VRC. So plus VRC plus VCE equal to 0. Thus VCE equal to VCC minus VRC. RC. Okay, so let this equation be equation number 3 or third equation. Okay, but we also know that the VRC equal to IC RC. Okay, so now substitute equation 4 into equation 3. So we will get VCE equal to VCC minus IC RC, where IC is given by DC beta times IB. Okay. Okay, so for the final part, let's consider this circuit to determine the voltage across the reverse bias collector base junction or the BC junction. Okay, so we know that VCB plus VBE equal to VCE. Okay, so VCB equal to VCE minus VBE. Okay, so that's it for today. And this is the reference book that I used for today's class or for this slide. Okay, thank you for watching and listening. Bye.